Certainly. So welcome. Thank you for being patient. For those who have joined us before, this is our third session in our what we're calling boot camp series. We're from Pass House, Western Pennsylvania. You can get our contact info. You can subscribe to our newsletter here. There's an address. If you haven't seen the first couple sessions, you can also go on YouTube. We record these. Just straight recording of Zoom, posted up to YouTube. That's the limit of my video editing
What's up, man?
abilities.
Yeah.
All right, keep going.
Yeah, so this is our third one. We're talking a little bit about the conference because we are not only interested in participating in the conference, but also we, as Passive House Western Pennsylvania, are a chapter of NAPHN, the North American Passive House Network. We'd invite you to join us. You can become a member. If you become a member of the national network, you would automatically become a member of your local group. If you live here in Western Pennsylvania, that would be us. Passive House Western Pennsylvania, we're not just Pittsburgh, we're a little bit wider, basically mostly the western half of Pennsylvania. There's a little bit of stuff in the middle that Philly shares. You can find it on our website. If you get our newsletter, there's a link to join there as well.
So the value of joining Passive House Western PA, and Jim and I are moderating this boot camp sessions for Passive House Western PA, is that you'll have access to Passipedia, which is a vast resource of Passive House tools and knowledge base things that you can have access to. There's discounts for events, discounts for training. NAPHN conducts all the training for certified Passive House consultants, tradesperson, and things of that nature. So there'll be discounts for all of that stuff as a member. We talked about the conference. For those who are late to the program, there's a discount code. Please feel free to use it.
Oh yeah, this is us. This is Craig and I. My name is Jim Bischoff. Work as an architect, Moss Architects here in Pittsburgh. Also a certified Passive House designer and on the board of Passive House Western Pennsylvania. Craig is from the Oros Group. I don't know if you want to introduce yourself, Craig, or we're on week 3. Maybe you don't need to introduce yourself as much.
Well, we'll send this out to everybody, so I think I know most people here. And Jim and I basically do a lot of Passive House work in the area, and we are collectively trying to promote advocacy around Passive House in Western PA. So we conduct events like this, we conduct training exercises, and we answer questions. And we have a pretty good eco network in the Passive House world. So we're looking for you to join us.
Great, thank you. And as we alluded to earlier, this is our third session. So the first 2 sessions in the past month, we've covered thermal insulation, thermal bridge free connections, and today we're going to do high performance windows and doors. I will add something that I heard yesterday when I was on the IFA webinar, which is the International Passive House Association, is that there's apparently some confusion that if you design a project using these 5 key principles that it's certifiable, which obviously is not true. And if you've missed any of our prior sessions where we talked about some of the certification and the metrics, we will be doing a future session about certification itself. What we're covering are the principles behind Passive House. It is not like some other certification, I guess, groups out there where you can check off some items and you count points and get a certification. But we'll get into that later in another session. Today we're talking about high performance windows and doors. And you can see the next ones will be in 2 weeks and 2 weeks after that, which we'll be covering air tightness and then ventilation systems.
And if anyone wants to do any further, I mean, we're going to continue the boot camps after session 5. We're going to get into PHWPA modeling, maybe some subcomponent modeling demonstrations like we did last week with thermal bridge analysis. We'll definitely be getting into some testing, some radar testing for blower doors and things of that nature. But if anyone in the audience has a specific subject matter you'd like us to touch base on, please send Jim or I an email. We'd be happy to make that a priority.
Yeah, I mean, our goal here is not to, we're not trying to replace the Passive House training course. We're trying to introduce folks to the principles and some of the ideas, let people ask questions mostly, right? We're trying not to do an hour-long presentation. Chris Hand is joining us, has volunteered to help us out today. He's from Steve Winters Associates. We were, when we were mulling over how to present Windows, we thought we've done manufacturer presentations before, and that's not what we want to do here. We want to talk more holistically about high performance Windows. Chris has this great article. Maybe some have read it. I put it in the invitation to try and get people to spark a little backup research and hopefully get some extra questions. But it's, we'll let Chris take over, introduce himself, and he'll do the presentation. And then we're gonna have plenty of time for questions. You can either, we hope people would put themselves on video or just audio and ask the question themselves after he speaks. But if you really don't want to, you can put it in the chat and Craig or I will read it for you.
Thanks, Jim. Chris, welcome, and thank you for being here with us.
Thanks a lot, guys. Yeah, thanks. Can you see my screen first?
Yes.
And you see the presentation, right?
We see it in non-presentation mode. We see the PowerPoint. There you go.
Good.
Perfect.
Great, thanks. So yeah, thanks, Jim and Craig, for having me on. I'm extremely happy to be joined this week to talk about Windows for Passive House construction. I love what you guys are doing here. It sounds like a extremely useful and practical way to kind of get Passive House knowledge out there. So just a little bit of background. Yeah, I work at Stephen Winter Associates in New York City. I am a certified Passive House consultant and kind of aspiring mechanical engineer. And I've been at Stephen Winter for about almost 4 years, working exclusively on Passive House projects, mostly large multifamily projects in New York and around the Northeast. And I do, a lot of time I'm spending is doing energy modeling, reviewing drawings, but also doing commissioning and inspecting and air tightness testing during construction. So I'm happy to be talking about Windows. Definitely spend a lot of time talking about Windows day to day, and we're only going to kind of cover a portion, but we're excited for this discussion. So just quick background: Stephen Winter Associates, shameless plug. We have we're about 125 staff across 3 offices: New York, Washington D.C., and Norwalk. We do a lot more than just Passive House consulting. We do energy and sustainability consulting for all sorts of different programs, green building certification, as well as accessibility consulting. We also have a podcast that launched last year that's very focused on a lot of building energy topics as well as accessibility. And there's a lot of great Passive House related ones on there if you want to check it out. So before jumping into too much specifics about Windows, I'm kind of take a step back, because I know this is the third in the series of the different Passive House principles, and I want to talk a little bit about why Windows are such an important part of the design process for Passive House projects, and why Passive House certification focuses so much on window and window performance. So you guys all know the Passive House design principles. I believe they're all on here in some some different order potentially, but I like to use this diagram because windows are such a unique part of the Passive House design package, because they allow you to not only have a good amount of control over the heat losses in your building, but also the heat gains. It's kind of something that's one part of your envelope that's very unique, and that you have kind of a wide you actually have a big responsibility to make the right choice with your windows, and that's why Passive House focuses on it so much. But why do we focus on it, so much? So we're going to kind of take a step back here. You can see quick credit, Stevens Institute of Technology logos here. This is actually from a graduate school course taught by Ed May, if you've met him before, who does a lot of the training up here in New York. But when we are designing a passive house project, and especially in the PHWPA, if you're into the modeling side of things, really what we're doing is looking at trying to balance the heat losses with the heat gains in a space, and that's what's required to maintain a constant temperature. Okay, right? I think we all generally get that concept and are generally aware, but that's what's happening when we're designing a building to maintain a constant temperature. So how do we get heat losses and how do we get heat gains in our building? Heat losses, the main two ways that we think about heat losses are transmission losses, meaning heat conducting through the actual building, and then ventilation losses or infiltration losses is actually just air moving out of the building. And so windows play a very big role in that, as you can imagine. The windows are the weakest part of the envelope thermally. They're going to introduce the most heat loss to your envelope. They, of course, also impact your project in terms of air leakage, and so that also contributes to the losses. But today we're not focusing as much on leakage, although I'd love to come back for another session and talk about that all day. But really what we're talking about today is the heat losses through your windows. In addition, as I mentioned, heat gains, there's internal heat gains, all of the equipment, people, whatever, that's giving off heat in your space, and solar heat gains. So again, we have windows are controlling, how we select our windows are controlling both a large component of the heat losses and the heat gains in the space. So it requires a good amount of understanding early on in design. So especially in a heating dominated climate like you are in Western Pennsylvania and we are up in New York, we're often very concerned with reducing our energy for the heating system. So how do we do that? And that's a kind of a central point to the passive house design process. How do we reduce this big kind of hatched portion over on the right here, which is the energy used by the heating system? Essentially, what we are doing with that heating system is using energy to make up for the extra losses that are higher than our internal heat gains and solar heat gains. So, and of course, within those losses, a lot of those losses are attributed to the windows themselves. So one very important way to reduce that heating system energy use, decrease the losses and increase the gains. Once you decrease those heat losses by choosing, for instance, a very good window, triple pane, highly insulated window, you're reducing those heat losses. If you use a higher solar heat gain window, a well-positioned window where you're taking advantage of higher solar gains, increase those gains, those both work together to decrease that heating energy that you're using for your building. So overall, you're reducing the amount of energy you're going to use for heating. So that's just short to point out how the decisions you make about windows and understanding the metrics behind them can have a huge effect in why we focus on them so much in passive house design. So passive house projects often push triple pane windows, highest efficiency windows that you can get on the market. And for that, one of the reasons, I think this is a great graph that kind of illustrates that, kind of going along with our heat losses and heat gains discussion. If you look at a single pane window in typical windows used across the industry, the heat losses through that window are typically going to greatly outweigh the heat gains over the course of a year. Again, this is really focusing on heating dominated climates. But as you get closer to something like a triple low E window on the right here, you can actually get to the point where your gains can outweigh the losses, and that can actually end up being a net gain for your building and offset the heating energy that you're going to use in the winter. Of course, this doesn't talk about the summer and keeping the sun out, but overall, if you can use that to your advantage to reduce your heating energy. So oftentimes modeling will look at which windows are going to be net gains versus net losses, and this is just an example of taking the result from a PHWPA and seeing which windows are resulting in net heat gains versus net heat losses over the year. So I wanted to start with all that because in this kind of gets back to the article that I think Tim mentioned earlier that I had written. The article is really about how to talk. I called it "How to Talk About Windows with a Passive House Nerd" is what the title of the blog post is. Because when I first got introduced into the Passive House community and started learning about Windows, I found that it was extremely confusing talking about U values and SH, solar heat gain coefficients, and all of these metrics that are used to define the efficiency of your windows, especially in North America, compared to what is needed for Passive House certification and Passive House modeling. So this section is going to try and kind of give a little bit of a background about, just kind of go back over what a U value is, solar heat gain coefficient is, if you're not familiar, and then talk about what the main standard that we use in North America, the NFRC standards that you might be familiar with, versus the ISO standards, which are typical for and required for Passive House modeling. So R value and U value is in short, R value is a resistance to heat flow measurement. We typically use this to describe walls, floors, that sort of thing. You're familiar with it in code. The reciprocal of that is a U value, which is the conductance of heat flow. You'll notice that the units are flipped, but it's essentially the kind of the opposite. The reciprocal of R value. The lower it is, the better the window. We typically use U values to talk about windows. I don't have a great answer for why we do that, but in general, when we're talking about windows, we're talking about U values. It's a heat loss per area. Next, we talk about heat gains with windows, and the way that we describe that specific to the window itself is with SHGC, which stands for, and I should have written it up here, solar heat gain coefficient, which is a measurement of the heat or radiation really that hits the window that is available to the interior space to actually potentially heat the space. Other things, of course, reduce the heat that comes into the window, dirt, radiation not hitting it directly, shading, but those are all separate. The solar heat gain coefficient is something that you specify in the glass that you are, in the window that you're buying. So we're going to talk a little bit about that today as well. So I wanted to just quickly go back over. We just talked about R values and U values. What that is a description of the heat flow through a unit area. In which we talk about in Passive House all the time, and you probably have gone over this. Just wanted to recap it. Is what's called thermal bridges, but the way we describe thermal bridges or linear thermal bridges is with what's called a psi value, spelled PSI. And denoted by this little Greek psi symbol, which you probably have seen in frat acronyms. But has the same units as U value, except you'll notice it's instead of per foot, instead of per square foot, it's per linear foot. So that is describing a certain amount of heat loss per length. And the reason why I'm bringing that up is because in Passive House terminology, in Passive House modeling, we just describe the heat loss around windows with not just U values. We use two kind of additional values that the rest of the industry really isn't familiar with. And most people outside of the Passive House world will likely might not be very familiar with these terms. And so one is called the psi spacer, which is the psi value that describes the heat of the spacer. So the spacer, right, is the material that's between the pieces of glass, the panes of glass, that gives it structure. And there's often going to be more heat flow at that point than there is at the glass or at the frame itself. So we have a number that measures the amount of heat loss per length of spacer. Additionally, and this is very specific to Passive House, we have what's called the psi install. The psi value that describes the heat loss at the window frame to wall connection. So that's, again, the number, you multiply that by the length around the window, and that will tell you how much heat loss there is at the frame to wall connection. So it's not a U value because it's based on linear foot. So the reason so everything we've talked about so far is somewhat general, somewhat specific to Passive House, but you know, in the US, if you're a practitioner and you work outside of the Passive House realm, I mean, most of us are very familiar with NFRC when specifying windows. This is a typical little label that you'll see sometimes on the window, NFRC values. And the critical thing to understand is that for Passive House modeling, for the PHWPA or WPA, if you're PHWPA for Passive House Institute, WPA for Passive House Institute US, the values that you use are different than these, and they're certified by the ISO, or an international kind of European standard. But what you'll typically see here in an NFRC label is the U factor. We'll get into what that really means, and the solar heat gain coefficient, like what we talked about before. U factor, you know, kind of another way to say U value, but it's meant to describe the entire window as opposed to each of the individual components. So let's say you're working on a Passive House project, someone gives you that NFRC data and you say, this is what I need for the PHWPA. So this is what the Excel spreadsheet looks like for the PHWPA when you are putting in the frame data. You've got your name, you've got the U value of each of the frames, you have a frame thickness, you have that size spacer number we talked about before, and you have a SI install. You're obviously not going to get any of that from that NFRC data. And that's so what we're going to go through a little bit is where can you get that data, and how is it different? So this is from the article, and this is trying to just kind of highlight the differences between NFRC and what's called ISO, which is what's referenced for Passive House modeling. So NFRC, the way that U factor that we saw on the previous label, which is also can be referred to as a whole window U value, that is calculated using by essentially calculating the U value for different components of the window and coming up with a whole window area weighted average. So they get the U value of the frame, they get the U value of the outer 2 inches of the glass, because the heat loss is going to be different there than the center of glass. Then they get the heat loss at the center of the glass. And you kind of add those all up together and divide by the total area. That'll give you your total window U value. ISO in Passive House does it a little bit differently. Specifically, there's no kind of glass edge area calculation. Instead, we have the SI spacer, like I mentioned before. So it's a slight different way to calculate it, but all that is to say is when you're looking up NFRC data, you're not going to find that size spacer value because it's not used in that calculation. Finally, kind of marked out in red here below is the SI install, which is specific to Passive House modeling. So these 2 boxes that I've highlighted in green are meant to show you that NFRC will only report that one value for the most part, whereas ISO will report all of these different values. And I'll get into it in a minute why that's important. So I mentioned this is just kind of building on that, the SI install, this addition of the SI install, that additional heat loss at the frame to wall connection, that's specific to the Passive House modeling. It's basically trying to be even more conservative compared to traditional energy modeling and capture that heat loss between the frame and the wall. So that was U values and SI values. And now let's talk about solar heat gain. So NFRC talks about solar heat gain similar to U value. usually as a whole window value. A lot of times you will see this presented as just an SHGC, and you need to kind of understand whether or not it's a whole window or just the glass, but usually it'll be the whole window. So the reason why that's important is because it includes the frame and not just the glass. For ISO in Passive House, it's actually technically referred to as a G value, not the whole SHGC. But that is measuring the solar heat gain just through the glass. So that's something to understand right from the get-go, is that the value used for Passive House is just the glass, whereas NFRC, it's usually including both. So as you can imagine, frames, which are opaque for the most part, don't let sun go through them. If you're including that in the area that you're evaluating for solar heat gain, it's going to greatly reduce the amount of sun that's coming through. So those values can be very, very different and should not be directly compared. I should have mentioned this at the beginning, but feel free to jump in with questions at any time. Let's see. And so this is just to show, similar to before we were showing the frame components going into the PHWPA, this is how you put in the glass component. You can see SHGC there and UG value. That's a little confusing because I just told you it's not, they don't call it they call it a G value. But long story short, you put in both of these separately when you define your piece of glass, and then you can apply it to different frame types. So why do these two distinctions kind of matter, and why does Passive House use ISO specifically? We'll kind of get into that. So as I mentioned, there's different, going into the Passive House model, you have a few different kind of U values, and as we mentioned, the psi values. There's the U value of the glass, there's the U value of the frame, there's the U value of the whole window, which is, again, just an area weighted value, including both of those, as well as the size spacer. And then the UW, what's called UW installed, which is a U value of the window that includes that psi install value, which is something you won't see referenced kind of outside of the Passive House modeling software, but ultimately is what is used in the heat loss calculation in the model. And the reason why Passive House breaks it down into those different components and why it's so important is because it gives you the flexibility in the modeling to account for the amount of frame relative to glass. So one very important point in all of this is NFRC standards define one U value for any window. But what you kind of miss when you think about just one U value is that windows can be all sorts of different sizes. And if you're including the frame and the glass in one number, you can only come up with one number if you define the size that you're talking about. So NFRC has done that. They've defined specific sizes for like operable, fixed window, storefront, where they are defining that whole window U value so that you can easily compare between different products. That's kind of the point of it. But for energy modeling purposes, it's not very helpful because in what this is illustrating here is if you have a window that has the same UF or U value of the frame, the same UG or U value of the glass, but different widths, you end up with very different overall window U values. So at the bottom, you can see a very small window will look a lot worse. It'll U value of 0.145, whereas a very big window, which is 10 feet by 6 feet, will look a lot better, U value of 0.11. The reason why that's so much better is because it has a lot less glass to frame. Sorry, a lot less frame to glass. It has a lot more glass in the overall ratio. And the glass is better than the frame. So when you area weight it, it's going to be better. So that's important for the modeling because, for the Passive House modeling, we want those individual units broken out so we can account for the different sizes of windows. That's kind of the long story short. So one of the big sort of takeaways is when you're talking about windows and when you're talking to clients and you're looking for products specifically for a passive house project, make sure you want to define if you're talking about NFRC versus ISO, because it has a big impact, and that's what these charts are trying to show you here. So on the left box here that's kind of marked in red, these are glass only values. So what this is trying to show is that if you were the calculation methods that are used, even if you're looking at just the piece of glass, are still slightly different because of how they define the calculation methods. On the right box here that's boxed out, these are NFRC values that actually include the frame again, this is for solar heat gain coefficient. You can see those are significantly lower than the similar ISO value. The reason this is important is if you were to specify an SHGC of 0.3, you might end up having a much lower G value that you need for your passive house modeling than you might expect. So you essentially can't it's hard to make a good comparison between ISO and NFRC. Going on that same vein, U values are also very different. So this is center of glass U value calculated based on NFRC and ISO. As you can see, NFRC is typically higher. It's something like 13 to 15% higher, but it actually gets better as you get to better performing windows. They get much closer, which is kind of good, especially because a lot of the projects we're working on are triple pane. But again, that's just to show, make sure you know which one you're talking about when someone's specifying a product. Okay, let's see, where am I at? 440. So Craig, what do you think? I included this last part where I could run through the passive house component databases, but do you think it might make more sense to open up to questions first, since in the interest of time, or what do you feel?
I mean, we've got time, so I mean, let's see if anyone has any questions, and then we should spend a few seconds going through the component database. I think it'd be very helpful for our audience. So, is there anyone who has any questions? If you guys have a question, please feel free to come off mute and ask, or put it in the chat, and then Jim and I will moderate that and ask the questions. Chris, I've got a handful of questions that I've started pulling up, but I wanted to give our audience a chance first.
Hey, Chris, interested in your thoughts on exterior shading devices. And, I've heard recently Monty Paulson talking about kind of designing for or taking into consideration exterior shading before you dial in window performance. How do you kind of see the relationship when you're starting a project to evaluate exterior shading?
Yeah, I'm not on mute, right? Yeah. No, that's a great point. Yeah, I think our approach is always start with potential exterior shading before dialing in the windows. I agree 100% with what Monty's saying, because that can have a huge impact on what solar heat gain coefficient you might want to specify based on the facade. I mean, if you think about it, if you have a window on the south side without any overhang at all, you might want to be careful with that solar heat gain coefficient, because in the summer you're going to overheat, right? Once you add that overhang, now you're only getting lower sun hitting the window in the winter. You might actually want to bump up that solar heat gain coefficient, because the sun that is heating your window is now going to be more beneficial and you're not as worried about overheating. So yeah, I definitely agree. Unfortunately, in a lot of projects I work on, there's not a ton of opportunity for exterior shading, at least in New York. But I would say definitely explore that first before defining at least your solar heat gain.
Thanks.
Any other quick questions before we go into the database component? Well, we'll start pinging you on the fly, Chris. Go ahead and dive into it.
Yeah, so so the component database, what just to take a step back, we want to, Jim, Craig, and I talked about wanting to step through this quickly because basically both Passive House Institute and Passive House Institute US have programs for certifying windows for use on Passive House projects. So what does that mean? It's you could talk all day about how they go through this process, but long story short, they have verified certain products that meet standards that they have set. Usually it has to do with the U value and the air tightness of the frame, at least. And they've determined that it's usable for Passive House projects, and then they actually provide a cut sheet that you can reference for your modeling that gives you all of those values that I was talking about before, the U frame value, the size spacer value, those types of things that you can actually use in your modeling, which is extremely useful. One thing I'll just clarify though is that these are not required. You're not required to use Passive House components to be certified. However, it does make certification much simpler because there's less vetting that the certification body has to do, but also it gives you the values right there that you can use. And there are a good amount of options. So let me just quickly, I'm going to switch out of the presentation mode and I have it pulled up here. So the Passive House Institute Passive House Institute in Germany has this component database. I've searched so many times, it's probably just comes up as my first thing, but I usually just search Passive House Institute component database. Similarly, Passive House Institute US also has a component database. So I'll first show you the PHI one. You get into this, it's a clickable house, it's kind of cool. You can actually just click on the component you're looking at. Usually just go straight to Windows over on the side. And then it gives you this list. I will say it's not the most, at least the PHI one's not the easiest to use. I usually do just a Control F if I'm looking for a particular manufacturer. But you can always just scroll through it, find a manufacturer, and then I'll show you. So Schuko is a brand that we've used a lot. You find the manufacturer, you can click on the name, and it pulls up this information here. It shows you kind of the profile of the frame, and it shows you these values, which this kind of aligns with the inputs of the PHWPA like we were talking about before. Then what you can do is you can click here, you can download the certificate, which you would ultimately want to have for certification. You can see it kind of shows a lot of that information. And then you use these values in the PHWPA. I will say with the PHI components, it will be in SI units. So you can see here millimeters, watts per meter squared Kelvin, which it requires you to convert it. But the PHWPA gives you that functionality, which is useful. So Theus, it's very similar. So this is Passive House Institute US. Go to component database. Yeah, at least I searched that and brings me to this page. Go to find and compare windows. And they have a pretty similar, but pretty cool kind of setup here where they've got the manufacturers here on the left, the actual model, and the glazing type. So you can get as specific as that, the frame model and the glazing type. And then it shows you which climate zones it's kind of suitable for, or like where you would it would be suitable for Passive House certification to be used. So one that we are familiar with using a lot is Intis. again, it does require you to have an idea of what glazing you're thinking of using, again, if you're starting out, you can kind of make a guess. But then I go over to the right and I click on this PDF, and it pulls up a similar sort of certificate, and it's of course laid out differently, has different units, but ultimately has a lot of the same information. One thing that is kind of nice is that they give these results for different U center of glass values, but really what you're looking for is the frame information. So you've got the frame height, that dimension there, the U value of the frame, and then that size spacer value. Those are really the three main things that you will end up needing for your window frame to be able to put it into the PHWP. What's nice too is they give it in both SI and IP units too. So that's just a quick, what's important about these is you can see here, it's calculation based on ISO 10077-2, these different standards, which are the ISO standards that Passive House references for the energy modeling. So it just makes it useful because you know what you need. Yeah.
So while you're on this page here with these two different databases, can you talk a little bit about if a project team just doesn't like that window or the windows in the database, what happens when you go through certification for PHI, for example, when you use a non-certified component of assembly? How do they go through the discount? How does that sort of work so that our audience knows that you're not beholden to the database and you don't have to use that?
Definitely. So there's a couple things you can do. I will say Passive House Institute US does make it a little bit easier because of course we're in North America where these ISO standards are less common. So no, you can definitely use non-Passive House certified windows. One way that you can do it actually is Passive House Institute US can take the NFRC data. NFRC does produce a pretty detailed output that they can kind of pull more information out from, not just that one U value number. And they can actually take that and turn it into equivalent values that you like what you're seeing here, and give that back to you and say, okay, use these in your model.
So they convert the numbers over, and then you'd still be responsible to do the SI install calculation to get all the numbers.
Exactly. Yeah, you're right. That's a good point. I didn't really focus that. The SI install is something that's on the consultant to do. Exactly. But they would give you, I don't think the frame height is no different, but it's really the U frame value that NFRC numbers are not going to have. They give you that size spacer value. The other thing is, sometimes more and more we're seeing more window manufacturers might actually have ISO data. So you could ask them. It's possible they've done this, they've done this testing as well.
So even without a triple pane window, you're seeing manufacturers starting to do the ISO calculations?
That's a good question. Non-triple pane.
Well, let me ask the question in a different way. How many projects have you been on where you can get away from the triple pane and use double pane because, it is one of the cost impacts for a passive house? There are savings in other areas like mechanicals when, you have smaller systems, but the windows are always, it's always our hurdle, right?
Yeah, definitely. So one big distinction is Passive House Institute in Germany. It's pretty much it's impossible to get certified without triple pane because they have very, very strict comfort criteria that you're just not going to, at least in our climate, in Northeast climates, you're not going to pass without a triple pane window. Passive House Institute US, we have had a handful of projects that have, maybe not a whole handful, but close to it, that have used double pane windows. So it's definitely possible. In fact, there might be some in that database. and the real difference is because that criteria is not as strict.
The thermal comfort criteria.
Yeah. Yeah.
Got it. Helpful. How many more slides do you have left, Chris?
Oh, that was it. Or let me see.
All right, so we're going to open it up to questions. Bhakti Dave has a question in the chat. She says, hey, Chris, you mentioned the solar heat gain coefficient in PHWPA is actually G value, right? Can we directly input the data from the component database and into solar heat gain coefficient cell in PHWPA?
That's a really good
question right there.
Yeah, no, that's a great question. You definitely can if the glazing that is in that certificate is the glazing that you're using. Now the problem is the chance that it's the exact same glass is low. You know, this is really focused on the frame values. I would say what we typically do is you get that G value from the glass manufacturer directly. And the glass manufacturer will have which might be partnering with the frame manufacturer, but the glass manufacturer will have their own cut sheet, and that's its own thing. You have to make sure that it's an ISO like calculated G value, but you can use these if it's the exact same piece of glass for sure.
Thank you. Audience, please come off mute and ask your questions. Dave, I've seen you come off. Go ahead.
Yeah, I'm curious, Chris, about, obviously we talk a lot about very, very specific requirements, specific glass assemblies, specific target SHGC and various, performance aspects of the glass. Any tips on how you guys are specifying in open specs or jobs that are going out for competitive bidding to make sure you can, kind of get the performance you're looking for in the model, but also hopefully keep it open to competition?
Yeah, let's see. So, when we do like a spec review for a project, we've already done a good amount of energy modeling at that point. And typically what we'll give a client is a range. Well, there's two different things. For solar heat gain coefficient, we'll often give a range. We'll say, don't go higher than this and don't go lower than this. And that they'll put that in their specs. They'll say, this is what we want for our glass. And then for the, so that kind of, leaves it up to, gives you a little bit of wiggle room, because I think like you're saying, it's sometimes can be hard to dial in a piece of glass to have the exact number that you want in terms of like that G value. So giving the range with the solar heat gain is good. And then for the U value, like I said, with PHI has this very specific comfort criteria. We typically say, the U value, we actually call out the U value of the center of glass and the frame and the side spacers separately in the spec. But what we'll also do is provide that kind of whole window U value, and we'll say cannot be higher than this whole window U value at this specific size. So we try to kind of have a couple different kind of backstops. But what we found is, that is a super good question, and we've definitely gotten burned in the past on projects that haven't had it clearly called out in the specs, but we want to be as specific as possible.
Hey, Chris, how about a different angle on the same question? Do you guys, Stephen Winter does a lot of large projects. That's really kind of your specialty. Have you guys got into government contracting where you have to be performance-based spec and be able to put in there a performance-based specification that can be competed in the market?
So we haven't done, well, at least our team hasn't done any government contracting, but basically you're saying, you're saying, yeah, I mean, none of the projects that we've been on have been required to be a performance-based specs, but we're essentially pushing projects to, I guess, make their specs be more performance-based. So, and it's definitely difficult, and I think we're kind of constantly learning and readjusting. That's something that is not easy, because, like I said, I mean, how many contractors are picking up a spec and seeing ISO-1000772 and have any clue what you're talking? Like, no one does. And so it's definitely something that's that's hard to figure out. But more and more contractors are getting used to it, at least in in the Northeast. Does that sort of answer your question?
Yeah, it does. So we have another question on the chat. Have you come across a project that requires triple pane windows to comply with PHI criteria, but could get away with double pane windows by complying with FIAS criteria, as criteria could be a little bit more relaxed depending on the location?
So the question is, have we found that?
Yeah.
Let's see. I know it's 100% been a consideration on many projects, that whether to go with PHI versus FIAS, because of the window, because of how strict the window comfort criteria is. So yeah, it's definitely been in consideration. I don't know if I can say that I know of any projects that have switched because of that, but it's definitely, I'm sure it's happened.
All right. Any other questions in the audience? Jim, do you have any questions on your side? I've got a few more, but I feel like I'm asking a lot of questions. So,
I mean, feel free if you want.
nah, I'm good. I got a few more I'll get in.
Yeah, go for it. I mean, I was going to ask a question that was sort of prompting question, right? So I get a lot of people asking questions about, kind of like the NFRC versus ISO, where you look and you feel like you're looking at a manufacturer's website. They're only giving you so much info. They often only give you so much info about glass, and you feel like you're limited. How much customization do you see happening on a lot of projects in terms of like the glass in combination with a frame or a window manufacturer you like? Are they people customizing the exact glass they find that gets exactly what they need? Are you limited to 2 or 3 options from a certain manufacturer? Like, how's that working in your projects?
I would say, in terms of the glass, I don't really know. I guess I've seen a lot of like 1 or 2 manufacturers, to be totally honest, but I do, if I had to guess, I believe that there's a pretty good number of options out there for the glass. I think it's I don't think it's as it's like as difficult, because I think when it comes to the glass, there, one glass manufacturer can, depending on the, assuming that they have triple pane and they can use pretty good spacers, based on the films that they put on it, they can achieve whatever visual transmittance and solar heat gain you're looking for. So I don't know. In my I can't say for certain, but my my kind of gut feeling is that there is a good amount of options out there for the glass, and if anything, it'd be more restricted in the frames. But
yeah, I guess it's out there. I think like often I see manufacturers, or maybe it's contractors, guiding like, hey, you've got 3 or 4 choices, and then folks coming and saying like, hey, this is what I want, but do I want to change to get the right U value? Do I want to change to get the right? And when my reaction is always, I know there's more out there.
Yeah.
I don't know why they're telling you that that's all you can get.
I just think there's kind of a disconnect between, there's not a lot of great resources in my opinion, for finding good products. And I have a couple of ideas, but I don't know if other people out there have good good resources for finding glass manufacturers and whatnot. That's something that I actually probably something I'm definitely lacking in.
Hey, Chris, we come across storefront a lot on these projects too, and we spend a lot of time talking about windows, punch lights, so to speak. I just want to see if you want to spend a couple minutes, because we're at the tail end of this, and just talk about how you go about storefronts from the same perspective, because you can't really get a triple pane storefront, you know.
You can
Not as easily as punch lights.
No, yeah. Yeah, that's true. So that's a good point. I mean, this is really very focused on just punch windows. Yeah, storefronts, you'd be surprised. A lot more. There are on the PHI database, I believe there is a whole let's see, where do we got it? Curtain wall systems. They at least have curtain wall systems. They don't really call it. Do they have glass walls in there? I don't know.
A lot of times we just take the hit on the storefront.
Yeah.
With double pane, because you have to, and then you compensate for it elsewhere.
Yeah, there's definitely we have had projects do triple pane storefront, but a lot of projects often do double pane. That often will work with Passive House Institute in the comfort criteria, because it's not in a living space, and you often will have some sort of perimeter heating around it. So yeah, that is definitely somewhere where we see more and more double pane. But we do have, but that's kind of assuming it's not in like living spaces and whatnot. It's more in the lobby and that sort of thing. What was I going to say?
That's true.
Yeah.
Unless you have like sliding doors for balconies or something like that in some multifamily. Yeah.
But we've seen those as triple pane, and there are there are passive house ones too. But yeah, in terms of like Passive House Institute, they're more worried about if it's near living space, or is it in a lobby or something like that.
They're more concerned with the thermal comfort than the energy performance.
Yeah, exactly.
You could seal them up just as tight as you can a punch light, but you're just going to lose it on the efficiency side.
Yeah.
Great. Are there any other questions from the audience? We're at 5:04, so we're pretty close, but we've got time for maybe one or two more questions if anyone has any questions.
There's one in the chat, Greg.
Go ahead.
Mark's asking, will retrofit window performance films contribute to the achievement for spec numbers? I guess it depends on your definition of contributing enough. I'm sure it does something.
Well, sorry. So the question is, retrofit films
yeah,
contribute to
the achievement for spec numbers. I guess they say.
Oh, got it. I haven't dealt with that too much. But I imagine if you're specifically working on a retrofit project, using a film to at least achieve a better lower solar heat gain, would certainly be something you could use to try and meet a certain spec. But I can't speak to that too much. I haven't really seen it.
And obviously it's not going to address frame, right? It's not going to address the installation detail.
Yeah.
And if it's an really old window, it's not going to address things like air tightness of the window. And I guess it depends on where you're starting too. What kind of window are you retrofitting?
Yeah, definitely. It's if anything, the solar heat gains probably, and the visual transmission is probably the only real thing I would think that you would have much of an effect on.
Yeah. Agreed.
Hey, Dave, you look like you have a question on your mind. No. Oh, you came off mute. I thought you might have wanted to ask a question. All right. Well, on behalf of Passive House Western PA, I want to thank you, Chris, for coming on and talking to us about windows. We are extremely grateful for your time and energy and experience. So thank you for sharing your thoughts on the boot camp. I appreciate it very much.
Thanks for having me, guys. I'd love to join for more in the future.
Absolutely, and that's a
Yeah.
great segue. So Jim, let me tee you up. There you go.
So we will be sending out info on our next session next week probably, but in 2 weeks from today, which is the 28th, will be our next session on airtightness. We haven't figured out all the logistics of that one yet, but you can count on the date and you can count on the topic for sure.
Thank you, Jim. And again, Chris, appreciate it very much. Everyone have a great evening. Thank you.